This tutorial will help you to answer the questions on homework 17. So the first section here asks you to identify if the relation shown is a function or not a function. When you have a table of values, you are not a function if you have a repeating x value, like here, with different y values. So that breaks the function rule. So this is not a function. If all of your x values are unique or different, like this one here, then you are a function. So all unique values would give you a function, but any repeating x values would be not a function. Remember, you're only concerned with the domain or the x values. Repeating y values do not matter. You can look only at the x values. If they are all unique or original, no repeats, you're a function. I know sometimes it gets confusing here where the numbers are the same but the values are different, right? That's a positive 3 and a negative 3. That is not a repeating value. Let's take a look at the second box here. When you identify the solution to a system of equations, you're looking for their point of intersection. If they intersect at all of their points, like this one here, then you have infinite solution points. Infinite solutions. If you touch at only one point, like in question number 3, then you name the coordinate at which they intersect. Remember, you name the x coordinate first, negative 3, and the y coordinate second, positive 2. If you don't intersect ever because you're parallel, then you have no intersection point, so there is no solution to that system. If you were asked to find the rate of change from 2 points, you would need to use the rate of change formula known as delta y over delta x, where you take your two values, your x and y values, right? So if I make a mini table here of x's and y's, then this is my first x value, my first y value, this is my second x value, and this is my second y value. So this would be the y's, y2 and y1. So don't forget there's a minus from the formula, so you're going to subtract these two values. And once you do that, your final answer is your rate of change. So in question 6, when I line up my values here and I get my y's, even if I reverse it here, okay, which it doesn't matter, be very careful when you're writing your values that you remember there's a minus from the formula, and sometimes there's also a negative in your value. And when you have 2 in a row there, it makes a positive. So the answer here is 5 over 0, which I actually have to go one step further. If you have a 0 in your fraction, you need to tell me whether you can divide by 0 or not. And when you have a 0 in the denominator, that is undefined, or that represents a vertical line. So you can't write this as your final answer. You have to go one step further. For question number 7, my y values actually match here. So negative 2 minus negative 2 over 7 minus 4, and that's going to give me a 0 over 3. Remember, if you have a 0 in your fraction, you have to interpret it. So zeros in the denominator are not allowed, but zeros in the numerator are okay. But if you have nothing and you split it into 3 groups, each group gets nothing. So don't forget, if you have a 0 in your fraction, you have to interpret that answer. Sometimes it's undefined, sometimes it's 0. Let's turn the paper over and solve our systems for the Wednesday box. So it says you can use either elimination or substitution. It depends on which method you prefer. Elimination method is usually used when the values are lined up, like x's and x's, y's and y's, and constants with constants, but you can certainly rearrange it if you prefer the substitution method. I'm going to use the substitution method to solve question 8. That means I'm going to remove something from this sentence and replace it or substitute it with an expression from the second sentence. So this says y is equal to negative 2x minus 8, so I'm going to remove the y, I'm going to replace it with a negative 2x minus 8. So all of this is going to replace that. So negative 5x plus 4, remove the y, and replace it with my substitute. Now I have what's called a single variable equation. I used to have two variables, and now I have only one. So I have many of them, but one type. Negative 5x, and now I'm going to distribute negative 8x, and negative 32 equals 7. These terms are on the same side, so I'm going to combine like terms. And now I'm going to solve for x. And when I'm done, I will get a value for x only, but a system has two variables in it. So even though I'm done solving for x, I'm not done with the whole question. If your question has two variables, then you have two solutions. So if I want to find the answer for y, which is my second variable, I need to take this value of negative 3 and plug it back into either of my equations. I'm going to choose this one, but it doesn't matter which one. So I'm going to keep the y, I'm going to keep the negative 2, but I'm going to substitute my x with its new value, negative 3. Right, so my new value is negative 3, and that means that y is equal to 6 minus 8. Y is equal to negative 2. Now I can take these two values, I can substitute them in here and here to see if it's true, and here to see if it's true, and if it is, then I know that my system is solved correctly. So for the sake of time, I'm going to move on to number 9, but you could certainly do that check step on your own. I'm going to use the elimination method here for number 9 because my variables are conveniently lined up and my coefficients of y match, right? So I'm going to add these two sentences together. Here gives me a 3x, this gives me a 0, and this gives me a 12. Divide both sides by 3, and I get my value for x. Now don't forget, you also have to find your value for y. And it doesn't matter which equation you choose. So I'm going to choose the second one, but it doesn't matter. I'm going to keep my sentence the same, but instead of writing an x, I'm going to replace it with its value, right? So instead of writing that x, I'm going to replace it with the number I found, which is 4. Negative 16 plus y equals negative 11. Add 16 to both sides, and I get my final answer for y. And now I have both answers for this system. The last one can be solved either way, substitution or elimination. I think substitution might be easier here because I would just need to remove the letter y and replace this in, and I'd have a simple equation to solve. But I'm going to show you the elimination method only because the last time we used it, we added the sentences together. But if I add these sentences together, none of my variables would eliminate. You see that? None of my variables would, whoops, that should be a 32. None of my variables would eliminate, and that defeats the purpose. So if adding the two sentences doesn't eliminate, you should try subtracting the two sentences. But remember, when you subtract all of the terms. So I'm going to subtract the y, I'm going to subtract the 6x, and I'm going to subtract the 19. So that would be my new sentence, and now I can combine them together. So technically it's like this isn't here anymore. I rewrote it. So y minus y is 0. Now this time I have to write it because the entire left side is empty. 4x's take away 2x, 6x is negative 2x, and 13 minus 19 is negative 6. Now I'm going to add 2x to both sides, and I'm going to finish solving for x. So x is negative 3, and now all I need to do is plug that in and solve for y. So y is equal to 4x plus 13, so if x is negative 3, then that means that y is equal to negative 12 plus 13. Y is equal to 1. All right, let's take a look at our last box here. On Thursday, I'd asked you to solve these single variable equations. Looks like they got some fractions in there, but that's not too bad. We can do this. 3 times x is 3x. 3 times minus 2 is minus 6. Rewrite the rest of this side. And now half of 6x is 3x. And half of minus 2 is minus 1. These two are on the same side, so that gives me a 10x. And now I'm going to subtract 3x from both sides. And now I'm going to add 6 to both sides. And now I'm going to divide both sides by 7. And since this is not a terminating decimal, I leave it as a fraction. This is done. I'm going to do the same thing for number 12. I'm going to distribute when I need to. And I'm going to rewrite when I'm done. So 8x minus 10. And now both sides have like terms. This one is constants, this one is variables. But either way, I can combine these numbers. And let's see. I'm going to subtract 2x here to try and keep my variable positive. And then I'm going to add 4 to both sides to get my variable isolated here. And then I'm going to divide both sides by 3. And it looks like we're done. And that concludes the tutorial for homework 17.